So I went out and on the spreadsheet I calculated the mean and the standard deviation for that set of data, and that's what I came up with. So then I set up the two hypotheses. Um, is the mean equal to 3.18 or is it not equal to, because it differs, and then the problem, all right? So it makes it a two-tailed test. You seem to understand that in the live session, so we won't dwell on it. So then I calculated the test statistic, right? And we came up with that 2.219. And then because we don't know that population standard deviation, and also this is a small sample size, I'm going to consider this a t statistic, okay? Um, One concern that I didn't check, and I'm not going to check, but uh, in order to use this t statistic, and I don't know if your book's making you do this, you got to check for normality. So is the parent distribution normal? And we aren't told that in the problem. So I don't know. Let's see, that's an issue. The other thing is the data normally distributed, and that you'd have to do a normal quantile plot if you wanted to check, and also check for outliers in the box plot. I'm not going to do that because it seems like they just want you to, do the calculation and check. So, but those are some concerns. So now what I need to do is we need to see what the p-value is, or see what the, to figure this out. So I'm going to remember this 2.219. I'm going to go out to the t-distribution table, and because we had 24 sets of pieces of data in the data set, we're going to do n minus 1 for the degrees of freedom. We had talked about that last night, I remember. So I'm going to just scroll across this highlighted 23 row until I come to that t-score of 2.219. But that's going to fall right in between the 0.02 column and the 0.01 column. So we know at the outside, at the very most, in fact, we know it's less than that because it's not, that t-score is further out than 2.177. So we know, just to get an estimate, the p-value is going to be 0.02 for one of the tails. And then to get the total p-value, we have to, because it's the two-tailed test, I'm going to take the 0.02 and double it, because this is a two-tailed test. So that tells me my p-value is no more than 0.04, and actually we know it's less than that because that test statistic was further away. So we can compare this to our level of significance of 0.05, and it certainly is less than 0.05. So the decision is we're going to reject HO. It looks like the average family size is not 3.18. It's different from that. And without some more sampling, we really don't know if it's greater than that or less than that. This sample certainly seems like it was greater, but that wasn't what we were testing. We were just testing if it was greater than, or not equal to. Okay, so I hope that helps. Okay.